Hello, everybody, and welcome to episode 2.5, every detector, every fault, where we're going to go through the details of the detection pack that I introduced in the last episode. With that, I wanted to maybe start with a quick recap. If you remember in episode 1, we went through K8sGPT. We introduced how you could build your own autonomous SRE with that framework, plug it into Gemini, plug it into Slack, do all those fun stuff. We also talked about the limitation of that, which is the ability to monitor specific metrics like memory leak. Then we went off into episode 2, where I introduced the K8sGPT Detection Pack, which is a way to augment that limitation by introducing a set of watchers that are listening to metrics and ConfigMap and other things. This episode is going to be very fast. It's or short. It's not going to include a demo. I'm just going to go through the more details describing each of the pack services that I introduced in the last episode. So please check out episode 2 if you want to see how it all works and how it fixed the memory leak. Again, this episode is not going to include any specific demo. Okay, with no further delay, I wanted to maybe start with why we've chosen that path. Those who are familiar with K8sGPT knows that there is an extension plugin, and it's called Analyzers. And the reason why we didn't choose that path and we went with the watchers is for a couple of reasons. One of them is the latency ceiling. So basically, the way K8sGPT does is it scans the Kubernetes APIs and resources every 30 seconds, so there's a short window. It's obviously limited by the size of the cluster, so the more resources it needs to scan, the longer it takes to actually complete the task. So if we add more resources into it, the chances that it will actually be able to meet that latency window is shorter. We could obviously increase the latency window, but that is becoming less and less useful. The other thing that is the scale limit. Obviously, when you're doing polling and you scan all the resources, including ones that were not really affected or not under a fault scenario, you're very much affected by the scale of the cluster. So the more nodes, it takes more time to scan the cluster. With an event-driven approach, we're less limited because we only trigger things that are under faults or have a specific alerts, and therefore it's much more scalable. So let's go through the list of services that we included in the pack. So this kind of diagram shows you the full pack. All the boxes in blue are the new things that we added to the stack itself. And you can see on the left the 2 letters or 3 letters that we use for each one of them. The first one is Alert Manager. In this case, we're basically extending on Prometheus and Alert Manager from the Prometheus stack, and we're mostly adding rule packs. So in the previous episode, the way we detected memory leak is built on that ecosystem. So it's not really a new service, it's a set of rule pack and what we call Alert Manager Bridge, which is aimed to take the alert itself and mitigate how we send it to specific destinations. So for example, the Slack or the Grafana one. And this is where we're handling the formatting aspects. The next one is Event Watcher. The Event Watcher is the same, basically called through the Kubernetes event API, and it's the same as what the K8sGPT is doing, just event-driven way. So it overlapped with K8sGPT in this specific one. The ConfigMap is, again, covering a resource that is not covered by K8sGPT. And as the name suggests, it looks at the configuration and show the difference and what have been changed through configuration. A lot of the faults, by the way, are triggered by that. The next one is the ability to see audit. There are certain cases in which we won't be able to see a certain faults if we don't monitor that resource. So audit log is, and I'll go through that in a few slides. And the pod log watcher is the only place where we can actually see application failures because we basically have a daemon set that runs in every node, and it will scan all the logs of the infrastructure, also the application itself. All of them reports into a common result CRD. So that means that it's the same format that the K8sGPT has been using. Therefore, it's pretty easy to use the same operator that we used in the K8sGPT to access now the extended list of results and detection that we're going to have. So from the external world perspective, this looks like a natural extension of K8sGPT. Okay, so let's go one by one. We'll start with the rule manager, the event rules. So you could see again, like I discussed in the previous one, we're adding a set of rules. And as I mentioned, the analyzer, the K8sGPT analyzer doesn't really deal with metrics. So from that perspective, it is completely blind to the slow memory leak we've seen in the last episode. By plugging this one, we obviously augment that, but we also now have access to the entire set of the Prometheus ecosystem. So that gives us a huge range of faults that we can cover, and we'll see the exact mapping of that before we complete the session. The next one is the event watcher. As I said, this is an overlap. So the difference between that and what K8sGPT is covering is that it's event-driven, meaning that latency is going to be much shorter. So instead of waiting 30 seconds until we get an event from K8sGPT, we can get it in 5 to 15 seconds. And obviously, it's much more scalable. Next in line is the ConfigMap Watcher. The ConfigMap Watcher is a way for us to monitor and things like feature flag, connection string, database connection string, obviously rate limit, TLS certification stored that are stored as data. Those are probably one of the biggest sources for a lot of failures. So that's why it's very important to look at them. The way we implemented it, though, it does require an opt-in, meaning that we ask the users to label critical changes, and we watch only for those critical changes. So that's a kind of a nice or interesting caveat that we need to be aware of. Obviously, we could scan everything, but that might be too much. So we chose that path in this specific implementation. Next in line is the audit log. There are certain faults, like someone trying to deploy a privileged pod into a restricted namespace. In this case, the deployment will fail, but we will not have any trace of that. The only place where we can actually monitor something like that is the audit log, and that's why we also added the audit log into the sources themselves. Next one is the pod log watcher. As I mentioned, if you remember, the pod log watcher is a way for us to, it's a daemon set. So it's unlike the other watchers that are listening to the Kubernetes API. In this case, we're actually adding a daemon set that would run on every pod, on every node. And it will scan the logs of the application and infrastructure itself. But the important thing to note is that it will turn it into metrics and send it to Prometheus. So unlike the previous case where we have a watcher that calls the Kubernetes API and then turn it into a CRD, in this case, we're not turning it into a CRD. We basically turn it into an alert that will go through the Prometheus and then go through the same alert route that we had previously in the first iteration that we showed how we integrate with the alert manager. So it's going to go through the same alert manager rule pack, and then alert manager bridge, and from that to result set. This will obviously give us the ability to see application error like the 5xx spikes, the TLS handshake failures, database connection storms, things that are mostly invisible to the K8sGPT. And this is a very important slide that shows the mapping between the actual fault category. And note that this is not a specific fault, it's a fault category. So behind each one of them, there could be hundreds of faults of that kind. So it's not like we're talking about 16 faults as total, it's 16 fault categories. And then we can see the mapping between the actual fault and the source where we can detect it. And this is a very important approach to note about, because in this case, unlike, if you like, most of the traditional monitoring system where we put sensors everywhere and we only do the analysis by correlation and heuristic kind of as an afterthought, to detect the failures. In this case, we start in a kind of an opposite order. We first of all define what type of faults we want to detect, and then we map the resources that will enable us to detect them. And then we're starting to see what's the right way to analyze it and process it. And again, it's almost the opposite way in which you would operate and do most of the observability system today. And this is, again, very important. Now we can see here that the alert manager is the main source of detection of most of the failures. So that's why it's a very important thing. And having a blind spot here basically in the K8sGPT is a big limitation because it wouldn't allow us to see many of the failures. You can see what K8sGPT does cover. So again, you could see that most of the things that are metric driven are K8sGPT is relatively blind to them. So by having this list, and by the way, P mean primary and S means secondary. Secondary means that it gives us more indication of a failure, but it's not really necessarily the most reliable way to detect it. But having it is another, if you like, evidence that this is true failure. And here we can see some overlap between some of the resources. And overlap is not a bad thing. Overlap means that there's going to be stronger evidence of a failure from multiple sources. That means that the chances that we'll detect it and do the right root cause analysis around it is obviously going to be much more accurate when we have more signals pointing to the same problem. Okay, so that's kind of conclude our session today. As I said, it's going to be short, no demo. So again, quick wrap. We went through the episode 1 where we introduced the K8sGPT with the limitations of the out-of-memory kill. Episode 2 where we show the first time introduced the event pack that we went through in this episode into more details. In episode 3, we're going to talk about how do we use embedded Prometheus to enable us to make the agent completely independent of third-party integration. That's obviously very useful because that means that if we want to start and do our autonomous SRE, we just throw the agent and it starts working without having to now go through the rest of the resources, at least with regard to covering Kubernetes. Episode 4, we're going to go through Argo CD as a way for us to do the remediation aspects. And episode 5, we'll go through some of the guardrails. How do you make sure that when there is a remediation triggered, we're not doing the wrong thing, and how do we watch for that? That's pretty much it. Thank you very much, and I'm looking forward to see you on the next episode. If you have comments, as I mentioned in the last time, or if you have anything that you wanted to add, please reach out, send a comment. I'll be taking it into account and to the backlog of this series of how do you build your own autonomous SRE. Thank you very much.